Hello everyone, in this video we're going to be solving a radical equation. So we have x squared plus 2x plus 3 is equal to the square root of 4 minus x squared. You know, in most radical equations we can square both sides and get rid of the radical. Let's go ahead and do that first. So if you square both sides here, obviously, you get the following. X to the fourth plus 4x squared plus 9 plus 4x cubed plus 6x squared plus 12x, and on the right hand side you get 4 minus x squared. If you put everything on the same side, you get x to the fourth plus 4x cubed plus 11x squared, and of course you need to combine like terms, plus 12x plus 5 is equal to 0. Now this is a quartic equation and there is a formula, there's a cubic formula, and then you can use the cubic for solving the quartic, but that's quite complicated. So this is not the best approach, obviously, and this equation is somewhat special. So we're going to be following a different approach. Let's go ahead and talk about that. So I do have the following, x squared plus 2x plus 3. So let's go ahead and take a look at that first. Now this expression can be written in with the help of perfect squares as x plus 1 quantity squared plus 2. All right. Now, why am I doing this? Because I want to obtain an upper bound or a lower bound for these equations. That's why I'm doing this. And you're going to see in a little bit why I'm using this approach. So this expression, obviously, x plus 1 quantity squared cannot be negative. Therefore, the sum needs to be greater than or equal to 2. In other words, the minimum value, if x is a real number, of course, we're going to talk about complex numbers separately. If x is a real number, this expression needs to be greater than or equal to 2. All right, let's establish that first. The next thing we're going to talk about is basically we have the radical, right? Let's go ahead and take a look at that one. Well, we have the square root of 4 minus x squared. What do we know about the square root of 4 minus x squared? Obviously, x squared cannot be negative. Therefore, the square root of 4 minus x squared is something that is going to be less than or equal to 2. Why? Because 4 minus x squared is always going to be less than or equal to 4. The reason for that is x squared cannot be negative. All right? So we do have like two inequalities here. And inequalities a lot of times will help us solve equations. So let's go ahead and take a look at that. All right. How does inequalities help us? So we have an expression on the left-hand side that needs to be greater than or equal to 2. And the right-hand side needs to be less than or equal to 2. Which means that they can only be equal if they're both equal to 2. All right? So this gives us the two results. X squared plus 2x plus 3 needs to equal 2. And then the square root of 4 minus x squared needs to equal 2 as well. Let's go ahead and take a look at the first one first. Now from here, we're basically getting something like, if you go ahead and work this out, you're going to get, and we had this expression already, right? X plus 1 quantity squared, right from here, plus 2. If that equals 2, that means the 2 cancels out and we end up with 0, which means that x needs to be negative 1. So from here we get x equals negative 1, which is good, right? Let's go ahead and take a look at the second one, which is the radical. We said that the square root of 4 minus x squared needs to equal 2 because that's the only way the left-hand side and the right-hand side are going to equal each other. So this implies that if you square both sides, of course, in this case it's okay, 4 minus x squared is going to equal 4, and from here you're going to get x squared is equal to 0, which implies that x is equal to 0. All right, so from the right-hand side and from the left-hand side of the equation, we are getting two different solutions. And obviously, there's a problem here, right? That's a contradiction. You can't have this different x values for different sides of the equation, which means that we do not have any solutions for this equation. Okay? So our conclusion is no real solutions. And of course, when I say no real solutions, obviously there are always solutions, and in this case, there are complex solutions. And if you go back to the original equation, which was a quartic, remember that? We could basically find the solutions to this equation as fourth degree, a quartic one. So there's going to be 4 complex solutions with no real solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed the video. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.